Great. So question 11. The height when the plant was first measured, well, t years, that means 0 years, which means 0.2 times 0 is going to be nothing. So our height is going to be 2.3. Take away 1.7 times e to the power 0, which means 1.7 times 1, which is 1.7. So if you take 1.7 away from 2.3, you get 0.6 meters. Showing that exactly 4 years after it was first measured, the plant was growing at a rate of that. Well, to get the rate of growth, as opposed to just the height, we need to differentiate what's on here. And that's why we use E, because differentiating E is actually quite simple. So we've got, there's our H, so dH by dt. We're going to drop the normal number, and then it'll be a case of the power is going to stay the same, but we multiply by the coefficient of t there. So negative 0.2 times negative 1.7 is positive 0.34. So that's our differential, so that's up 1 mark. And then when t equals 4, we will be substituting into that, so it's going to equal 0.34 to the power negative 0.2 times 4, which is negative 0.8, and if you pop that into the calculator, it'll give you 0.1527 and so on. So they're talking, so that does round to 0.153 meters, which is 15.3 centimeters per year. According to the model, there is a limit to the height to which this plant can grow. So if you're getting confused, you might want to put it on your thing and see what the graph looks like. It might take a while to get it centered in the right place with the scale and everything. But the point is, we're going to be taking away from 2.3. Now, we're never going to get a, as this value here goes towards 0, because we're not going to get a negative value to take away. So as t tends towards infinity, the value of this is going to tend towards 0. And because we're doing to a negative power, and so the bigger the negative power, the smaller that's going to make the number. So therefore, the limit is going to be 2.3 minus 0, which is 2.3 meters.